We want to solve this inequality. But just before we solve it, let's be reminded that when it comes to inequalities, anytime you multiply both sides by a negative number, the signs must switch around. And if you multiply by a positive number, the sign remains. For example, if you consider the scale, temperature scale, 0, 1, 2, 3, 4, 5, 6, 7 degrees Celsius, -1, -2, -3, -4, -5, -6, -7, all right? If you consider that 3 degrees Celsius is a higher temperature than 1 degree Celsius, right? Because 3 here is higher than 1. So 3 is greater than 1. If you consider in the negative range now, -3 and -1, what happened? -3 is below -1, is less than. All right? So you see that? The sign switches around when you turn them negative. All right? Now, you might also consider this. Suppose you had multiplied by 2 and you say 1, or let's say 3 degrees Celsius is greater than 1 degree Celsius. If you multiply both sides by 2, you're going to have 6 is greater than 2. Because guess what? 6 is up here, 2 is down here. 6 is higher than 2. But if you take this and multiply both sides by a -2, you're going to have -6 comparing with -2. How does it go? -6 is down here, -2 is up here. Obviously, -6 is below -2 on the negative side, so it's going to be -6 is less than. So you see how the signs switch around. You have 6 is greater than 2, -6 is less than -2. So remember that. Now, with that out the way, let's come back to this. You have 21 divided by x minus 18. It may seem that what you're going to do is say 21 over x minus 18 is greater than or equal to 1, and then you multiply both sides by x minus 18. But if it was an equation, that's what you would do, right? Multiply by x minus 18, multiply by x minus 18, and then x minus 18 cancel x minus 18. So you would have 21 is greater than or equal to x minus 18. But you wouldn't want to do that. There is a problem there. What that problem is this. You see the x minus 18? You don't know whether it's positive or negative. You don't know what x is. If x was less than 18, then you would have a negative. For example, 17 minus 18 is a -1, right? What would happen if x was equal to 18? The division would be indeterminate, because you would have 18 minus 18 equals 0, and you're trying to divide by 0, which can't happen. Now, if x is positive, if x is greater than 18, for example, 19 minus 18 is equal to +1, then you could multiply both sides. But you don't know what x is. That's the problem here. So you can't just multiply both sides by x minus 18. So, what do you do? Alright, what you want to do here is get a 0 on the right hand side. Right? On the right hand side of this. Now the argument here is this. If you have an expression that is greater than or equal to 0, and it is a number 1 divided by a number 2, whatever it is, it means that you have a positive divided by a positive, or a negative divided by a negative. Remember, positive divided by a positive gives you a positive. And positive number means it's greater than 0. Negative divided by a negative is also positive, which also will be greater than 0. So let's try that. So get a 0 on the right hand side, and then you can move on from there. Or you get the 0, 21 divided by x minus 18. What you're going to have to do is subtract 1. Well, it will be from both sides. So you have minus 1 on the left. Is greater than or equal to 1 minus 1 on the right. But 1 minus 1 is 0. So you have 0 here. Alright? Now, make some adjustments to this. So you have one thing divided by another. So you don't have to mix it up with the plus and minus, whatever it is. So what you do is say 21 divided by x minus 18, that's a fraction, minus another fraction. Put 1 over 1 to make it look like a fraction. Greater than or equal to 0. Let us draw the line and find the LCM. I want a nice straight line here. LCM of the denominators, LCM of x minus 18 and 1. You have to remember your fractions now, your fractions calculation. That's x minus 18, right? X minus 18 into x minus 18 goes 1 time. 1 times 21 is 21. Minus 1 into x minus 18 goes x minus 18 times x minus 18 times 1. Gives you x minus 18. You have to put it inside the bracket here because it's subtracting all of it. Alright? It's greater than or equal to 0. Now what happens after this? We have up top, we have 21 minus x plus 18, right? Negative 1 times x, negative 1 times negative 18, positive 18, right? So it's like you're saying plus negative 1 times what is in the bracket, right? So here, over x minus 18 is greater than or equal to 0. But here now, you have, it would be negative x, 18 plus 21 is what? Plus 8 and 1, 9, 2 and 1, 3, plus 39 over x minus 18 is greater than or equal to 0. Now the thing is this. Since they are great, the answer that you get is greater than or equal to 0. Which means that the answer you get when you divide these is a positive. It's either 0 or a positive number, right? Now, what happens is this. You're going to say that either negative x plus 39 is positive, that means greater than or equal to 0. No, not either, it is both. Both are greater than 0, right? So is this and x minus 18 is greater than 0, right? So either this is so, or it's negative x plus 39 is a negative number, is less than 0, And also, x minus 18 is a negative number, less than 0. Notice that I say x plus 39 is greater than or equal to 0, because the top, the numerator, can be 0. 0 over anything is 0. But I did not say that the x minus 18 is greater than or equal to 0 or less than or equal to 0. Because x minus 18 cannot be equal to 0. It can be greater than 0. It can be less than 0, but not equal to. Alright? You cannot divide by 0. X minus 18 cannot be 0. So, less than, greater than, or less than. There should be no equal to here. Alright? Now, what this means is that you have a positive over a positive to give you a positive, or a negative over a negative to give you a positive. Alright? Now, let's consider the first case. If x plus 39 is greater than or equal to 0, right? Then what you have is that x is greater than or equal to negative 39. You see that? And x minus 18 is greater than 0. Then x will be greater than 18. Alright? So that is one case. So now you will find that in sometimes one of the cases cannot work, only the one can work. So let's consider the two of them first, and then later on we're going to look at a number line and see which one of them would not make sense and which one would. Now, if it is the case that negative x plus 39 is less than or equal to 0, then what happened? I messed up the then here. Then, what you're going to have is negative x minus 39 is less than or equal to 0, because I added, oh, what am I doing? Come, let's do that again. The negative x is less than or equal to negative 39. Alright, see that? I subtracted 39 from both sides. And then if I multiply by a negative 1, right? Then what happens is positive x is greater than or equal to positive 39. See that? And then this case now that accompanies it is x minus 18 is less than 0. So if x minus 18 is less than 0, right, then what you have is x is less than 18. So this is the other possible case. Now what happened here? Let's take a number line and see if we can see exactly what's going on. This goes, alright, let's say our 0 is here. We have negative 39, and we have positive 39, negative 39, alright? Let me just check back on something here. That's minus x, good. Alright, so negative 39. We also have a positive 39. We also have number 18 in both cases. This is 8. No, 18 would be on this side. Now, this case up here, let's consider this one. X is greater than negative 39, greater than or equal to negative 39, and is also greater than 18. Okay. Now, it would mean that 19, 20, 21, and so on would work. Alright? Now, let's consider this one. X is greater than or equal to 39 and less than 18. Let's consider the second one and see if it would make sense. We have our 0. 39 is up here and 18 is here. We're saying that x is greater than 39 and at the same time x is less than 18. That can't be. You cannot have numbers that are less than 18 and at the same time they're greater than 39. So this one definitely cannot work. Now, we are saying here now that x can be greater than or equal to 39, negative 39, and greater than 18. So, let's check out what the situation could be. One possible number that we could try. Suppose we try 0. 0 is not supposed to work because x must be greater than 18. Even though it's greater than negative 39, it should be greater than 18. Let's put in 0 for x and see what would happen. Now, 21 over 0 minus 18 is greater than or equal to 1. Right? 21 over negative 18 is actually less than 1. So we see that our assumption is right. 0 couldn't work for x. Suppose we try 17 for x. That's not supposed to work either. Let's just try that. 21 over 17 minus 18 must be greater than or equal to 1. This means 21 over 17 minus 18 is negative 1. But 21 over negative 1 is the same as negative 21, and that's less than 1, so that can't work. Alright, so let's look back at it now. 18 cannot work because it means that you're going to divide by a 0, right? If we try a negative 18, something on this side, suppose we try negative 18, it's not supposed to work, 21 over negative 18 minus 18 must be greater than or equal to 1. But it's going to be 21 over negative 36, and that is going to give you a negative answer. And the negative number is less than 1. Alright, so we see so far that these numbers are not supposed to work. Right? With the equation, any number going back is not supposed to work. The numbers must be greater than 18 and also greater than negative 39. So let us try 19. 19 should work. 19 for x, that should work. 21 over 19 minus 18 is greater than 1. So it's 21 divided by 19 minus 18 is 1. Alright, 21 divided by 1 is actually greater than 1. So it works. right? So that works so far. Once you pass 18 going up, those numbers work, right? If you try 100 or any other number bigger than 18, it would work. So once you pass the number that is greater than 18 and substitute it for x, then this would work. Alright? So you see that. Alright. So, any questions, comments, and so on and so forth? You can put it in the comment section. Alright? I'll see you in the next video.